carbon fiber spars that protrude out here. The control system is installed. A landing gear or carbon fiber flex plate is already installed in the model. We're going to show you a cutaway section just a minute here so you can see the details. These lines, along with the instruction package that we showed earlier, show you how to cut out the flap section and the aileron section and the landing gear wheel well. Now, already inside of each panel are the hinge blocks and the leading and trailing edges for the ailerons and the flaps. And then, of course, these are the locations of the hinges that you install. Inside of here is the landing gear flex plate system, and we're going to show you a cutaway wing in just a second. And then these are blade spars that actually join the two wing halves together. Now, it's very important to remember this model has a removable wing. The wing can very easily be bolted with 4 bolts taken off of the fuselage in just a matter of seconds. This is the control rod. It's already installed in the wing for the bell crank on the aileron. Now let's take a look at what this wing panel looks like as it comes out of or is partially finished as it comes out of our jig. You'll never see a lot of this in the airplane, but this is all inside of your model. We use a few ply ribs. We use lots of spars, as is the technique in full-scale fighter structure now. And we use lots of carbon fiber bracing that actually replace the many balsa wood ribs you're accustomed to. As we said, the bell crank system is installed. And the landing gear, this is a composite of carbon fiber and glass, all made in a press and processed. And this is what we call the landing gear flex plate. It is a perfect memory spring that's mechanically bound to the main carbon fiber spars. The landing gear actually bolts onto this, retractable unit bolts on here. And this will allow you to make just absolutely terrible landings and not hurt your model. This is a spring and it absorbs the shock. It is also very good for grass field operations. In designing this model, we wanted to emphasize the capability to use this airplane off of grass, and so we built a flexible landing gear mount system that will help absorb the shock of a turf operation. Inside the wing, after you cut off the aileron and the flap, these little pieces of wood are already in there, and they allow you to slice in and bury the hinges as appropriate into the proper blocks. Again, let me remind you that all of the detail of what to do is explained and illustrated in the manual. The stabilizer sections, of course, they're much simpler, but they are built very similar with a couple of plywood ribs, and they have a lot of carbon fiber ribs and some spars in them, and these 2 little blade spars that protrude out each end, which we'll show you how that is inserted into certain formers in the fuselage. And the fin is a nice airfoiled affair. Again, a very simple structure using carbon fiber as the center of the leading edge, so you can sand this down into a very pointed affair, the same way for the stabilizer. So the real work of construction is already done for you. You do have to do some shaping of the elevators. And the reason the elevators are not pre-shaped is that there's a very, very thin slit in here which you'll insert a carbon fiber strip into. You'll zap that in there, and then you plane and sand the elevators to shape and put in the necessary blocks for the control horns. All explained in the instructions. Now, this particular package contains the die-cut pieces necessary for the formers in the fuselage and a few pieces in the wing, the wheel well liners, and the strakes. There are 2 types of strakes depending on whether you have the Aggressor model or the F-20 model. The strakes are simple little devices. It's really an option. We provide it in the kit. We provide the instructions on how to use it, and we provide some information as to why you would want to use them or why you may not want to use them. But they're little high lift devices that project from the leading edge of the wing up to the fuselage. So those parts are in this bag. You've all seen die cut parts before. These are nice quality ones and they do the job. The accessory package is full of bell cranks for the flap installation, the nylon bolts, the hinges, the control horns, every nut and bolt and screw and fitting that is necessary to finish this model is in this package. It contains some very precisely, specially made parts, all molded out of carbon fiber filled nylon. These parts form the hatch attach group and the cowl keeper group. And they're molded just for this model and future Biojet model airplanes. Now this particular little part we call the hatch latch, and it's just a little spring-loaded device. It has a pin projecting out of here. It is mounted into the fuselage and supplies us the easy on-off release that you've seen in the operation part of the film. Then there are these hatch pins. They're little cylindrical topped, hollow cylindrical topped plastic parts and a fin base, a pin base. And then the receptacle that they actually go into is also a specially molded part. And we'll show on this completed or partially built airplane here just how these pins are utilized and why we did them and why it helps making your fan model a little bit easier to work with. These little devices and the O-rings that come with them, we call them cowl keepers, and on the finished model we can also show you the operation of them. It just allows easy access to the fan system and actually inside the duct without the use of any nuts and bolts and rubber bands. I just don't like the looks of rubber bands on jet models. A very significant part of the Sport Shark series kits and any kit that the Biojet product line will produce is carbon fiber. We have an entire product line of carbon fiber products called Magnolite. And when we first got into developing jet model airplanes, we found real weaknesses in the airframes when using ordinary products. Either they were weak or they were heavy. And once I was exposed to this space-age material, carbon fiber, it became obvious that it was going to have to become a very important part of our model airplane if we wanted to have a strong, lightweight model with various components such as a wing removable. So we actually, quite by mistake, got into the business of producing carbon fiber products or the Magnolite product line such that we could have these products available for our kits, develop the prototypes, and eventually manufacture the products for the kits. Now, carbon fiber has had some bad press in that it was associated with boron in one article written by what I feel very irresponsible journalist in Model Aviation a couple of years ago, where he actually got people afraid of the product. There is no, the only thing you can say about the relationship of carbon fiber and boron is that they're both space-age materials, and that's the end of it. We do not use boron, we use strictly carbon fiber in our Magnolite products. Here we have the two wing panels that have been joined using the fuselage as a jig, and joining the blade spars with the machine cut carbon fiber composite angle or dihedral braces. Some of those little angles that we showed you are used here and here for the forward wing mounts and used in the junction of the spars and the plywood rib to strengthen that joint. The aft wing mounts are carbon fiber blade spars with reinforcement on one side that are already installed in the wing when you get it. Carbon fiber again is used in the trailing edge of the wing so that we can sand it down to a very nice streamlined section. Then again, we have the hanger rack preventative type of structure there. This wing shows the wing wheel well cutouts, and visible inside are some of the carbon fiber reinforcements there. We've shown you the airplane, various component parts, shown you a little footage on the performance of it. If I've still got your interest, let me show you what makes the whole thing go. What we're showing you now are the various pieces and parts that come in the Biojet fan-powered system, and exactly how they come to you. Let's start off by looking at the fan shroud and stator engine mount assembly. This is the way that you get the unit. Okay, we're going to look all over this thing and I'll try to explain it. We have first an injection molded, carbon fiber filled nylon housing or fan shroud. On that housing, the engine mount lugs or fan mounting lugs are an integral molded part. You don't have to put them on, they're already there. The remote needle valve mounting bracket is already mounted onto the unit. The engine mount itself is an aluminum cast affair, as we're bolting the engine to aluminum, not plastic. We don't want to transfer the heat of the engine through the bolts into plastic. We transfer it into an aluminum casting. Now, attached to the top of that casting, or an integral part of that casting, is what we call the primary stator. The primary stator has the function, or similar function, of the other stator blades around the periphery here to straighten the flow, and just as important, and this is what's very significantly different about this fan, is that this stator spreads the flow as it proceeds back from the fan to the engine that sits back here. Now, we spread that flow to get it around that engine. Up in the top here you can see a little cooling duct. We take a little bit of that flow, or the necessary amount of flow, to cool the engine cylinder, the cylinder head. And then of course the engine fins will stick out just ever so slightly on the side here. So we'll get cooling there. We have all the cooling that we need. We're not wasting fan air to cool unnecessarily. Okay, so we have the engine mount, an integral primary stator, and the injection molded secondary stators. And this comes assembled just as you see it. And before this assembly is packaged up, it's put on a lathe, and this ring that the fan runs in is trued relative to the engine shaft, so that when you bolt the blade on here, it's perfectly centered in here. You don't have to do any sanding or refitting. We've done all that for you. You might notice these ribs on the outside of the shroud. These are just strengthening members that give the fan unit what we call hoop strength, such that it holds its shape. The fan rotor itself comes assembled, trued, and balanced exactly as you see it. The blades, although it looks like a one-piece out of the mold operation, the blades are molded individually, assembled on carbon fiber plastic discs with the spinner, and then a very precision machined aluminum rotor disc is screwed through each blade into the spinner. And then the blade is put on a lathe and trued and balanced before it is shipped out. So that's the way you get it. No assembly and no balance necessary. And of course the fan blade inserts in the shroud and spins like this. Now we're able to maintain a 15 to 20 thousandths gap between the blade tip and the shroud, because the entire fan unit is mounted via these little pieces. It's sort of like a servo is mounted. These are rubber pads, and there are little rubber sleeves that go in here, and this bracket holds them all together. And this allows the fan unit to move very, very slightly in the model as the engine passes through its various vibration cycles during the throttle up and the throttle down. Any reciprocating engine has cycles of vibration. And it's not enough to disturb the model, but it is enough that if the rotor is securely bolted to the engine shaft, it's going to move. If we don't allow the whole shroud to float in there, we're going to eventually cause rub and wear and an increase in the clearance between the blade tip and the shroud. And that clearance is relatively important to the efficiency of the fan. This entire fan assembly design point was 85% efficient. That means we're converting 85% of the horsepower into thrust out the back. The 15% that we'd like to think we could get to make a 100% efficient unit just can't be had because of the frictional losses of the air rushing through the ducts at very high velocity. That efficiency ratio is in the neighborhood of 15 to 20% better than the next best thing on the market, primarily because of the rotor design, a computer-generated rotor design that turns the flow into almost perfect axial flow, and because of the constant area ruling that we showed you as the air comes back over the beak or that primary stator, the the shroud itself is expanded out of round as necessary, such that any cross-section through here is a constant area with any other cross-section at the same stage on another part of the fan. So, for all intents and purposes, except for the little bit of cooling air that we tap off as necessary to cool the engine, the fan blade does not know that the engine is sitting in the back. It does not feel the pressure of the engine in the duct, or the back pressure, which is a very measurable loss. After the fan air goes through the stator system, manages to cool the engine a little bit, as we've talked about, then the fan air is picked up by these fairings. This one was mounted to the top hatch. It's removable from the airplane out of the tailpipe section. This top fairing is designed to take the flow as it comes off of the cylinder. It's a little bit turbulent in here. It straightens it back out and lets it enter the airstream again in a laminar flow situation. The center body, the air that comes off of the center body, that aluminum casting and the mount of the engine, is then streamlined by this fairing, which is another fiberglass part. We'll show you in just a second how you get that in the kit. And that flow is streamlined back into the flow to eliminate turbulence, to eliminate low pressure bubbles that are commonly associated with other fan systems. Now, since this one removes very easily with the top part of the exhaust duct, we also had to make this system removable and make it such that it wouldn't fly out the back of the tailpipe under a little vibration. So we manufactured the necessary brackets that attaches to the engine, and it's more or less an O-ring type of shock mount system that we can actually reach into the duct and just pull straight back, and that fairing will come off and allow us access to the carburetor. If we remove the tune pipe, which is an O-ring retained system, again all custom made to do the job properly, we now have access through the duct to the carburetor, any part of it. If we needed to, we could actually pull all the parts out of the engine through this access except the shaft and the bearings. Now these fairings come to you molded out of the epoxy glass similar to the model, and the only assembly you have to do is bolt your engine in and do some minor modeling work to glue this fairing on and paint it, glue these two halves together with a former in there and the necessary retaining brackets. So it's not really much of a kit. The hard work has been done, the precision work has been done. The only thing we ask you to do is do a little bit of modeling with these fiberglass parts to form the fairings in the back. We used a remote needle valve system so that we can keep your hands out of the duct. You don't have to go in the duct fishing with screwdrivers or other devices to set the needle. It's all very conveniently on top of the engine, on top of the fan shroud. Here we can see that rubber mount system allowing the unit to move, and this is the throttle connection. This is the only thing that's in the duct that we would like to somehow get rid of, but we can't. It's the necessary little 55 thousandths diameter piece of wire that controls the throttle. Now, the KBV engine, as we said earlier, was developed by John Brodbeck and myself to do the specific job of powering a ducted fan model, and most specifically the Viojet system. And we used the technology and some of the parts that they had developed for their boat racing 67, and we made every part in the engine as precisely as we could for the specific purpose of accomplishing this jet model propulsion. The engine case itself is not a bolt-together affair such as many. The actual front end of the casting and the main part of the casting is all molded in one piece, making a stronger, lighter unit. The material that's used in the engine shaft itself is a very, very tough to machine, but worth the effort, very, very strong steel. The ABC piston and cylinder has the proper taper in it, the proper porting in it to give us a reliable, high-power engine that will also idle in transition as well as produce approximately 4 horsepower. Ladies and gentlemen, I want to thank you for your attention and your interest in our project. We hope we've been informative here. We hope we've shown you what our efforts have to offer. We want you to become involved in this very interesting new facet of the hobby, ducted fan and simulated jet power model airplanes. The performance, the reliability, the enjoyment level is considerably higher than it was a few years ago. And we want you to get involved, whether it's with our product or some other product. We do invite you to compare other products. Now, that's what we're doing with this film, is trying to show you our products, emphasize what we feel is important, and we invite you to compare. And if we can be of any service to you, we certainly, that's our business. We want to. So enjoy the rest of the film. We got a little bit of hot dog flying, some precision pattern maneuvers on the film. Enjoy it, and if there's any questions that we haven't answered here, please feel free to contact us. Thank you.
Bye.